Have you ever looked at the steel structure and wondered why are there so many different shapes and sizes of those metal beams? It might seem like overkill, but there's a fascinating world of engineering behind the seemingly endless variety of steel sections. Today, we are diving deep to uncover the secrets behind this structural diversity. Hello, my name is Jagdish and welcome to Civil Artifacts. First and most important point, different loadings require different handling, and it is greatly influenced by how is your steel cross section shaped. Imagine a bridge. It has to withstand the weight of vehicles, the force of wind, and even the impact of an earthquake. Now imagine a skyscraper. It needs to resist the immense weight of its own structure, plus the constant push and pull of gravity and wind. These varying loads demand different strengths and resistances from the steel components, and you will be one and bigger step closer to a mishap if you don't pay attention to what kind of section you are using for your structural steel. Let's look at some of the commonly used structural steel cross sections. There is a huge list of shape and sizes of steel cross sections, but here are some cross sections which are in often used today. I-beams or H-beams with their wide flanges and deep webs are champions of bending resistance. Think of them as the backbone of bridges and long-span structures, effortlessly carrying heavy loads across significant distances. Channels, on the other hand, are masters of shear resistance. They are often found in roof trusses, where they efficiently transfer lateral forces. Wide flange beams. Wide flange beams, boasting even wider flanges, are the heavyweights of the steel world. They are the go-to choice for skyscrapers and other structures demanding exceptional bending strength to support massive loads. Steel bars, like round and square bars, most common use of them is of reinforcement. You might have seen these in almost every concrete building, which is built around you. Now let's talk about span and deflection. The longer the span, the more a beam tends to bend or deflect under its own weight and the loads it carries. That's where the depth of the section comes into play. Deeper sections offer greater resistance to bending, minimizing deflection and ensuring the structural integrity of the bridge and building. Imagine a long suspension bridge. You wouldn't want it to sag significantly, would you? That's why engineers use deep I-beams to ensure the bridge remains stable and safe, even under extreme conditions. Now, let's address a critical concern: stability. Tall structures like skyscrapers are constantly battling against the forces of gravity and wind. A key consideration is the risk of buckling, where a slender column can suddenly collapse under compressive loads. Hollow structural sections, or also called as HSS, with their uniform cross-section offer exceptional resistance to buckling. Their hollow core provides a more efficient distribution of material, enhancing their stability. The slenderness of a section also plays a crucial role. Stockier sections with a lower height to width ratio are less prone to buckling and can better withstand compressive forces. One more reason for so many different steel sections is aesthetics. Aesthetics also play a significant role in the selection of steel sections. Architects often choose sections that not only provide structural integrity but also contribute to the overall design and visual appeal of the building. You'll see exposed steel beams in industrial style buildings, where the raw strength and form of the steel are celebrated. In contrast, more slender sections might be used in modern minimalist designs, creating a sleek and elegant aesthetics. And finally, let's consider the practical aspects of construction. Some sections are easier to fabricate and connect than others. I-beams, with their simple recognizable shape, offer straightforward welding and bolting connections. More complex shapes like curved or tapered sections might require specialized fabrication techniques and adding to the overall cost and construction time. Transportation and erection on site are also factors. Certain sections might be more challenging to handle and install, requiring specialized equipment and skilled labor. Likewise, there are many reasons for why we have so many different kinds of shapes for steel sections. So there you have it. Now you know why we don't use I-beams for roof purlin and why we can probably use channel section alone in the heavy load areas of bridges. The seemingly endless variety of steel sections is a testament to the versatility and adaptability of this remarkable material. It's a testament to the ingenuity of engineers who carefully select the right section for the right job, ensuring the safety, efficiency, and aesthetic appeal of our built environment. If you're curious to learn more about the fascinating world of steel construction, or you have any doubt, leave a comment below and I will try to get back to you as soon as possible. And don't forget to subscribe for more insightful content on the wonders of engineering.